Okay, so this is lesson number 94 in Algebra 2, and the name of this lesson is called Dependent and Independent Variables, Functions, and Functional Notation. Now, you may get into this and be like, oh my gosh, are you kidding me? When will I ever use this? Well, this is something that is kind of putting you over the line with higher level math. If you're in calculus, college algebra, college trig, any of these upper level math courses, all of this stuff will be necessary in order for you to succeed in those. So let's start with dependent and independent variables. Now you're used to, at this point, using x's and y's. Alright, so the independent variable is the one that you give or assign a number to. So let's say I have y equals 2x plus 4. And I make a table like this. And usually what I do is I put in a number for x to see what my y is. So I put in a 0. So 2 times 0 is 0 plus 4 is 4. Alright, so the number that I assigned, or the letter that I assigned a number for, is my independent variable, means it's independent of anything else. I can put any number I want in for x. And what happens then is when I put a number in here for x, then it is multiplied by this 2, added to 4, and it gives me a y value. The y value doesn't have a choice on what it is. If I put in a 2 for x, the y is going to be stuck, at least in this equation, giving me an 8. So the y is called a dependent variable because it depends, the value we get here depends on the value we put in here. So we put in any number we want for x, and then the y is dependent on what number we put in here for x. Okay, so we put in a 3. We could pick any number in the whole history of the world for x, and we chose 3. And when we put it in there, do we have an option for y? No. Y is going to be 3 times 2 is 6 plus 4 is 10. So the 10 is going to go here. So y, that number 10, is dependent on what this number is. This 8 is dependent on what this number is. The 4 is dependent on what that number is. And that's pretty much it as far as dependent and independent variables. Now the x can be a dependent or an independent, and the y can be a dependent or an independent. It just depends on which one you assign a number to. But normally the x is the independent variable and the y is the dependent variable. Alright, so let's look at functions, and a lot of this is just theory, just understanding what's going on. Alright, a function. When we have an equation that has, again, two variables, okay, we put in an x and it spits out a y, okay. We have a match. Whenever we put in a number for x, it will always give me a y value. So it doesn't matter, again, what numbers we put in here, it will give me a y value when I put in an x. Okay? And when that y value is assigned to like 0, when we put a number in here, we put 2 times 0, 0 plus 4 is 4. Okay? If I put in a 0, will I always get a 4 in this equation? Can I ever get any number but 4? No, I can't. So what they did is they came up with a name called a function. If we put in a value for x and it will only give me one value for y, then it's called a function. Okay? In fact, in the book it says a special name for equations that have only one answer for y for every value of x. So let me show you a couple different ways to express a function, just so that you are aware of that, because there's about 3 or 4 different ways that we're going to be going into. So let's say I put in a 4, and when I put a 4 into the equation, it gives me a 3. When I put in a 2, let's say when I put it in the equation, it gives me a 16. When I put a 0, it gives me a 27. Okay? that is considered a function because every x has one y value. Now what if I put in a 0 and I got 27, but I also got 12? So when I put a 0 in, I got two different answers, a 27 and a 12. Now my x is giving me more than one y value. It's given me 2. So therefore, that equation is not a function if one of my x values can give me two different y values. Now let me show you something else. If, let's take away this, and let's say that I put in a 3. And when I put in a 3, I also get a 27. Okay? That's okay. Each one of these x's only points to one y value. It just happens that 0 and 3 both point to the same y value, but 3 only points to one number, 0 only points to one number. It's just these two point to the same number, and that's okay. So, when you show it in a graph like this with vertical lines like this, you can only have one arrow go to one number. Okay, the minute I make this go like that, I have a number, but I get it going two different places, so therefore it's not a function. Alright, so that's one way to determine it's a function, by looking at it. Another way is by using coordinates. So if I have a 3, 4, and a 4, 6, and a -3, 2, okay, because I look at my x values, that's all I care about. I don't care what my y values are, but if they give you a long list of numbers and all of my x values are different, then these coordinates are a function. The minute I make two of my x values the same, here and here, it automatically means that it is no longer a function. So if you look at the x values and none of them are the same, then it is a function. If you have a drawing like this and from the left side to the right side it only has one arrow pointing from the number to the number over here, it's a function. Notice here, 0 only has one arrow, 3 only has one arrow. They just happen to point the same way, and that's okay. Alright, let's look at functional notation. So we are moving along here on page number 392. And what we're doing here in functional notation is normally what we would do is we would write y equals 2x plus 3 when we write an equation. Well, what we're going to do is we're going to change the y, and we're no longer going to put it as y. We're going to call it f of x. Everything is the exact same. Basically what f of x is another way of symbolizing y. And what it means is, what is the function when we put a number in here for x? What are we going to get? So if I were to go f of 3, what did I just replace x with? 3. So that means on the right side I'm going to replace x with 3. And that's going to give me 9. So f of 3 is equal to 9. So all that says is when I put 3 in for x, I'm going to get 9. Okay, so that's all that's saying. Nothing really freaky or anything. It may take a little bit to kind of get used to it, but I mean, gosh, I went years and years and years without understanding what in the world that meant. Nobody ever explained it to me. So f of x means, what is the function of x? G of x, h of x, those are pretty much your standard ones. They all mean the same thing. If I put x in, what is this going to be equal to? So let's go ahead and look at a couple here before I run out of my time. I have 15 minutes per video. Okay, it says if we have h of x, and this is example 94.3, and if that equals 4x minus 3, and we also have p of x, which again, both of these just mean basically y, equals x squared minus 3. Okay? if it says find p of negative 3. Okay, what that means is we look at the equation here. We have two equations. We look at the one with the p. We just throw this one out. It's not asking anything about h. So we just look at this one. And it says whenever we see an x, we're going to put a negative 3 in its place. Okay, so 9 minus 3 is going to equal 6. Now I notice for p of x, I wrote it down wrong. They have a 3x there, but it doesn't really matter. Let's do it as if it was 3x with p minus 3. So p to the negative 3 is going to be negative 3 squared minus 3 times negative 3. So 9 plus 9 equals 18. So p of negative 3 with this new equation where I put an x there is going to be 18. That's it for this lesson. Not really a whole lot, but I would like to do a couple of the practice ones here. So notice it says which of the following sets of ordered pairs of x and y are functions. So if you look at A, notice when you go across there are no x's that are the same. So that's a function. If you look at B, are there any x's that are the same? Nope. C, any x's that look the same? Nope. D, any x's look the same? Yep. There's a 3, 2, and then if you go down a few, you've got a 3, 0. So your x repeats itself. You've got a 3 in the first one and a 3 in the third one. So that means that is not a function. Alright, so if you look at E, they say if h of x equals 7x minus 2 and p of x equals x squared minus 5x, find p of negative 5. All you're going to do is plug negative 5 in for the p of x equals x squared minus 5x. You're just going to put the negative 5 in there for x, and you're going to ignore the h of x. I don't know why they even put that in there. Sometimes what they'll do is they will give you h of x, and they will give you an equation, and you will see this later. And then they give you p of x, and they give you an equation. And they say find h of 2 and p of 3. So what that tells you is they want you to take the h of 2 and take the top equation with the h and put the 2 in there. And then on this one, they're saying, well, you've got a p, so let's take this equation, and we're going to put (9 minus 15 is negative 6). Okay, so you get two answers there if I were to do that. It just depends. You're just going to use this equation for the h of 2 and this equation for the p of 3. And that's really all there is to that. So it shouldn't really give you much trouble there for lesson 94. And we'll keep doing some of those.